Okay, so I think a good place to start analyzing this model is to think about what will happen to these three equations here when we don't have any persistence in the white noise shocks. So that means that every day the shocks are totally independent of what's happened in previous days. All right? If that's the case, then the best expectation that people will have about the steady state, about the level of output and the interest rate tomorrow is just going to be the steady state level of those two variables. So these expectation terms actually are all just zero. So you'll recall that these are log differences, right? So, again, notation, but here we just write yt, but what we really mean is the difference in the level of output today. Maybe I should get rid of the tilde then, since I'm not going to have another little yt. We mean the difference in the output today minus steady state. Okay, so if our expectation I'll just write it out, little yt, it's just going to be our expectation of these two terms. And our best guess about this value tomorrow is just going to be 1, because log of y0, not 1, but our best guess about log of yt tomorrow is just going to be log of y0. It's as good as we can do, so that will be 0 if there's no persistence in the white noise shocks. Okay, so we can just cancel all of these guys out. All right. So then let's rewrite the equations just with what's left over, with no persistence. And we get these guys here. All right, so we have three equations, but you can see that what we want to do is we want to put everything on the variable. We want to put the exogenous variables on the right-hand side and the endogenous variables on the left-hand side. So what I mean by that is these white noise shocks, we want them all on the right-hand side, and we want these variables on the left-hand side. And it turns out that you can see that the interest rate here is just a shock. So we're just going to replace that, and then we're going to solve for yt. I think we can do that. Let's see here. Did I do it on the next slide? Let's just do, oops, my bad. Sorry about that. So just for fun, just a little algebra, let's actually just solve these. So we can rewrite yt is equal to -1 over theta, not rt, but u. I think I'm going to drop the t's actually. Let me rewrite this just so there's less notation since they all have a t. So y is going to be equal to -1 over theta times u mp plus u is. Pi is going to be equal to kappa times -1 theta ump plus u is, right? I'm just substituting in the value of yt here, plus u pi. All right. So I mean, this is essentially what we want. You can simplify a little bit here, but you can see we've already got the endogenous variables on the left-hand side and the endogenous variables on the right-hand side. Okay, so let me just flip to the next slide where we've written those out. It's the same as we had from the last slide. Okay, and let's see what we've got here. Notice that this u here is like the shock to the interest rate. So what we have is that when the interest rate is high, unexpectedly, output is low relative to its steady state level. When the interest rate is high relative to its steady state level, then inflation will be low relative to its steady state level. Okay, so that's exactly what we kind of expect to happen with monetary policy. And notice here that it's not the rule that matters here. You know, the central bank has a rule, that doesn't matter. The market can predict that. What matters is these white noise innovations. So it's the unpredictable part of the central bank's interest setting policy is the part that actually has an effect on inflation and the interest rate. Recall, that was exactly the point of this Lucas information model, was that it was the unpredictable part of the shocks that matter. The same point is also there in the nominal rigidities section we talked about as well. Okay. So yeah, so that's kind of the most important thing to say here, I think. So this is the case with no persistence. A general case where there is persistence is what just central banks actually use, sort of a more complicated version of this same model, but with the same flavor is what central banks use to set interest rates. So there's that. So let's think about a more general model. So let's think about a model where the shocks actually have persistence, which is more realistic and more interesting. If so, then now I'm just kind of telling you about this experiment. I haven't actually simulated this. I think this is actually from the book. But let's assume that utility is log, and then assume that the profit margin, kappa, is 0.13. I say the profit margin, but that's basically how much output today affects the interest rate. So that relationship there. Okay. So if there's no persistence, then as we just saw on the last slide, the change in output is just 1-for-1 with the change in the interest rate. The change in the interest rate is, of course, just the shock, as we saw on the last slide. And then finally, the change in the interest rate, well, it's going to be kappa times the change in the interest rate. So the change in the inflation rate will be negative kappa times the change in the interest rate. Just to flip back one slide, that's exactly what was on this last slide. So theta is now equal to 1 by assumption. So yt is just the negative of ump, and inflation here is just the negative of ump times kappa. Okay, so that's where this came from, exactly from the last slide. Now let's add some persistence so that if the shocks are high today, we expect them to be high tomorrow as well. Well then, the change in output due to a change in the interest rate is going to be more than 1-for-1. Okay, so that's kind of the main message here. And you can say the multiplier for macro 101, that IS curve multiplier, that's back. That's right here. That is what we're looking at here. That is the multiplier. So there was a long time in macro where people moved away from those old-fashioned Keynesian models. They thought they were too simple, and they weren't micro-founded. Now we've kind of come full circle. We've added micro-foundations, and we're back to the multiplier. If the government prints a little bit of money, then that money sort of gets multiplied out in the economy, and there's a larger effect than what the original amount was. So there you go. All right, I think that probably would be a good place to break this video.